Somewhere right now, a bank is processing millions of transactions through a database system that has been running continuously since the 1960s. If that system crashes, and they do crash, the entire institution depends on a recovery strategy that was designed before most of us were born, and that still works flawlessly today. That system is IMS. And today I want to understand exactly how it protects itself. My guest has spent years building and maintaining IMS environments at major enterprises. Jordan, welcome.
Thanks for having me. And that framing is exactly right. IMS is quiet infrastructure. Nobody notices it until something goes wrong. My job is to make sure nothing goes wrong, and when it does, that we get back up in minutes, not hours.
Before we dive in, tell us a bit about where you've used this stuff. What kinds of systems are we actually talking about?
I've worked on IMS environments at financial institutions and insurance companies, places where a single IMS database might hold decades of customer records and process thousands of transactions a second. The recovery strategy isn't just a technical concern, it's a regulatory one. Regulators require you to prove you can recover, and how fast. So everything we're going to talk about today has real stakes attached to it.
For someone who's never touched IMS before, pure beginner, how would you frame what backup and recovery actually means in this world?
Think of IMS like a library that never closes. Thousands of readers are checking out books and writing notes in them simultaneously, all day, every day. Now imagine the library catches fire. Backup and recovery is the plan for rebuilding that library. Not from scratch, but from the last photograph you took of every shelf, plus a complete diary of every change made after the photo was taken. Put those two things together and you get back to exactly where you were before the fire.
So the photograph is the backup, and the diary is the logs?
Exactly. In IMS terminology, the photograph is called an image copy, a point-in-time snapshot of a database. The diary is the IMS log, a continuous record of every single database change. Recovery means restoring the image copy and then replaying the log entries on top of it, walking the database forward to the exact moment before the failure. That's what we call forward recovery.
And there's a backward direction too, right? What's that?
Right, backward recovery, or backout, is for a different problem. Say a batch job runs for 3 hours and then abends, crashes halfway through. You don't want those half-applied changes sitting in your database. Backward recovery uses the log to undo the changes that program made, rolling the database back to the state it was in before the job started. It's surgical, only that program's changes get removed. Everything else stays intact.
Let's talk about the log in more detail. When people say the IMS log, what are they actually referring to? I keep seeing acronyms such as RLDS, SLDS, and I lose track.
So the log is really a chain of data sets, not a single file. While IMS is running online, it writes every database change into what's called an RLDS, online log data set. Think of it as the notepad sitting on the librarian's desk. It fills up fast. When an online log data set gets full, IMS switches to the next one and kicks off an archive process that copies the full online log data set to a longer-term storage data set called an SLDS, system log data set. The SLDS goes to tape or disk and is kept for however long your recovery window requires. Maybe 30 days, maybe a year.
So the online log dataset is the live working log, and the system log dataset is the archived version?
Exactly. And this archive step is important for another reason. It also creates an RLDS, a recovery log dataset, which is essentially a filtered copy of the system log dataset containing only the database change records, stripped of the overhead. The recovery log dataset is what the recovery utilities actually read when they're replaying changes. It's faster and smaller than the full system log.
So at recovery time, you're reading from recovery log dataset rather than system log dataset?
Exactly. And this archive step is important for another reason. It also creates an RLDS, a recovery log dataset, which is essentially a filtered copy of the system log dataset containing only the database change records, stripped of the overhead. The recovery log dataset is what the recovery utilities actually read when they're replaying changes. It's faster and smaller than the full system log.
So at recovery time, you're reading from recovery log dataset rather than system log dataset?
Often, yes, or from change accumulation datasets, which we'll get to. The key point is that the log chain must be complete and unbroken. If you're missing even one archived log between your image copy and the point of failure, your forward recovery stops cold. You cannot skip a link in that chain.
Let's go deeper on image copies. How often should you be taking them, and does IMS have to go offline to do it?
The frequency depends on your recovery time objective, how long you can afford to replay logs. If you take an image copy once a week, and your database has 6 days of changes logged since then, recovery could take a long time. Most production shops take image copies nightly, sometimes more often for heavily updated databases. As for going offline, IMS supports 2 modes. Batch image copy requires the database to be offline, which gives you a clean, consistent snapshot. But IMS also supports concurrent image copy, which lets you take a copy while the database is still in use. The trade-off is that the concurrent copy is fuzzy. It may contain in-flight transactions, so DBRC tracks a bit of extra log data to reconcile that fuzziness during recovery.
So, you don't always have to take the database down for backup. That's important for a system that supposedly never stops.
Absolutely. And there's a third option worth mentioning: incremental image copy, which only captures the blocks that have changed since the last copy. That dramatically reduces backup time and storage, at the cost of a slightly more complex recovery that might chain several incrementals together. For the highest velocity databases, that's often the right call.
Let's talk about checkpoints. I know the word from other contexts in gaming and machine learning, but in IMS it seems to mean something very specific.
It's actually quite similar to the gaming analogy. A checkpoint in IMS is a recorded save point. When IMS writes a checkpoint, it takes a consistent snapshot of its own internal state, which transactions are in flight, where all the data is, what logs are active, and writes that to the log and to a special structure called the restart data set. If IMS crashes, it doesn't have to replay all logs from the beginning of time. It finds the most recent checkpoint, restores from there, and only replays changes from that point forward.
So checkpoints make restarts much faster.
Dramatically faster. Without checkpoints, IMS would have to read back through every log since the last image copy, potentially many hours of data. With frequent checkpoints, it might only need to go back a few minutes. There are 2 checkpoint flavors worth knowing. System checkpoints are written automatically by IMS at configured intervals during online processing. Program checkpoints, written by a chkp call inside a batch application, serve a similar purpose for long-running batch programs. They allow the program to restart midway through rather than from the very beginning if something fails.
Wait, so the application programmer can also write checkpoints? It's not just an IMS infrastructure thing?
Exactly. And it's one of the reasons IMS programs tend to be structured a certain way. A good batch program checkpoints periodically, say every 1,000 records processed, so that a failure 3 hours and doesn't mean starting over at record 1. There's even an extended form called symbolic checkpointing, which lets you save your program's own data along with the IMS state, so you can pick up not just where the database was, but where your application logic was too.
And now the piece I've been most curious about, DBRC. Database Recovery Control. What does it actually do?
DBRC is the central nervous system of IMS recovery. It doesn't store your data, and it doesn't run your recovery utilities. What it does is remember everything about your recovery environment. Every image copy ever taken, every log data set ever archived, every recovery ever performed, every database reorganization. All of that history lives in a set of data sets called the RECON, Recovery Control Datasets, and DBRC is the component that reads and writes the RECON.
So the RECON is like a permanent ledger, an audit trail of everything that affects recoverability?
Precisely. And that ledger is what makes automated recovery possible. When you need to recover a database, you don't have to manually figure out which image copy to use or which logs to apply in which order. You issue a genchcal.recov command to DBRC, and it reads the RECON, works out exactly what's needed, and generates the JCL, the job control, for the entire recovery process. It knows the starting point, it knows every log to apply, it knows where to stop. That's enormously powerful.
What happens if the RECON itself gets corrupted or lost?
That's the nightmare scenario. IMS actually maintains 3 RECON data sets, 2 active copies updated simultaneously, and a spare. That redundancy exists precisely because the RECON is so critical. Lose it without a backup, and you're doing manual recovery. digging through log timestamps, figuring out sequences by hand. It can be done, but it's painful and slow. Best practice is to back up the RECON every time an OLDS is archived. So RECON backups are as fresh as your log archives. And those RECON backups must travel off-site along with the image copies and log archives, because a disaster that wipes your primary site wipes all three if they're co-located.
Here's my favorite question. What's the single thing most people get completely wrong about IMS backup and recovery?
That taking image copies is the backup strategy. I've seen organizations with beautifully scheduled nightly image copies who have never once archived their logs off-site. They have the photograph, but no diary. And without the logs, the best they can do is restore to last night, losing an entire day of transactions. In a banking context, that's catastrophic. True backup strategy is three things together: image copies, a complete unbroken chain of archived logs, and a healthy RECON. All three. Every time. Tested regularly.
Tested regularly, meaning you actually run the recovery?
In a test environment, yes, absolutely. Untested recovery is theory. The first time you find out your RECON backup is corrupt should not be during an actual outage. Good shops run practice recoveries quarterly. Some do it monthly. You'd be surprised how often the drill exposes something: a log archive gap, a RECON backup that didn't actually complete, an operator procedure that's out of date. The drill is the strategy.
If someone is new to IMS administration and wants to build a solid backup and recovery foundation, where do they start? What's the first thing to get right?
Register your databases with DBRC. That's step one. Some older IMS environments have databases that are not registered, usually because they were set up before DBRC was well adopted. Unregistered databases can still be recovered, but DBRC can't help you. You lose the automated JCL generation, you lose the log tracking, you lose the image copy registration. Once you're registered, set up a schedule for image copies. Nightly for high-change databases, weekly for quiet ones, and make absolutely sure the log archive utility is running automatically every time an OLDS fills up. Then back up the RECON at every archive. That three-step rhythm, image copy, archive logs, backup RECON, is the heartbeat of a healthy IMS shop.
And the change accumulation utility, where does that fit?
Change accumulation is an optimization step. It takes all the log entries since the last image copy, sorts and consolidates them into a single CA dataset. When recovery time comes, reading one CA dataset is far faster than reading dozens of individual log archives. It's optional in non-data sharing environments, but mandatory in data sharing, where multiple IMS systems share the same databases, because there you have separate log streams from each system that need to be merged into one coherent change history. DBRC, again, manages all of that coordination automatically if you let it.
Jordan, this has genuinely changed my mental model of what database backup means. It's not one thing. It's a layered system of snapshots, logs, and a central memory that ties them together. What's the single line someone should walk away with?
Recovery is a chain. Every link matters. You need the image copy, the unbroken log archive, and the RECON to tell you how to use them. Miss one link and the chain breaks. And you're doing it by hand at 2 a.m. while an executive breathes down your neck. Get the chain right before anything goes wrong, and you'll barely break a sweat when it does.
That's the kind of line you want tattooed somewhere accessible. Jordan, thank you for making something genuinely complex feel navigable. If this opened up the IMS world for you, drop a comment below. I'd love to know which piece landed hardest. IBM's official IMS documentation and the links in the description are the best next step if you want to go deeper.